Hi everyone, this is Swain Fang from Wuyu Innovation. Thank you for having me here. Our office is located in Taiwan and our customers are mainly domestic companies or individuals. Today I'll take a few time explaining what we do and give you some examples about how we leverage 3D printing in our works. Basically, what we do is to design and make product prototypes for customers from various sectors, meaning our customers brought their ideas to us and we turn them into a functional prototype, allowing them to demonstrate it to the investors or use it for crowdfunding. We try to cover everything during the prototyping, including circuit design, firmware coding, and of course, mechanical design such as making a 3D printed enclosure for the product. And because of the nature of our business, we do not focus on certain types of product or application. And the product we design could be very different from one to another in terms of material, designing tool, and manufacturing processes. Unlike many companies who take 3D printing as a tool to verify the design of their products, many of our prototypes were for one-time use, and many of them won't even go to volume production, such as devices for research, artworks, or props for movie production. So it's important for us to broaden our design capability, and every new request is just like a journey for us to learn something new. The company's name, Wuyu, is from Chinese. It means no boundary. It describes how we position ourselves as a service provider, and it also describes how we feel about having 3D printing as our most powerful tool because we can do so much more with it. Thanks to the diversity of Formlabs resins and nylon powders, we are able to address many issues for different applications by choosing the right materials. I believe many of you share the same experience as we do. That is, in early time of our business, we chose FDM 3D printer over SLA 3D printer because it's more affordable, the efforts on post-process is less, and most importantly, the strength of materials such as PLA, PETG, or ABS are way better than the resin of SLA 3D printer at the time. And just a few years ago, we came to know that the development of resin has been way beyond our understanding. So many resins for different purposes have been made available, and the post-processes like washing and curing can now be handled by automatic machines with minimum efforts. This picture shows here is a coupling that we designed to connect a motor and a wheel. In the past, we would have printed this with PETG, which is known to be resilient to impact, but they still broke over time, just like the one on the left. And for experiment purpose, we printed the coupling with Formlabs clear resin on Form 3, as you can see on the right. It took us by surprise that it can better withstand the torque of motor, even though the resin is not designed for such purpose. And that's when we know our understanding about SLA 3D printing and the resins need an update. Today, we still use FDM 3D printers for rapid prototyping, but the majority of printing works have now been gradually transitioned to SLA 3D printers. Let me walk you through some examples. Here's the first example. The customer is a filmmaker who asked us to modify a scale model of a beach buggy into a sci-fi style or cyberpunk style flying vehicle. We started with a concept sketch on the left, and the result is on the right. This is a good example showing what we can do. Firstly, we need a circuit and firmware to control the lighting effects and the fans. And we need to make those parts which didn't exist by 3D printer. So we started by removing the wheels and put on some new skins which were printed by Form3 using TUB 2000 resin. We used TUB 2000 resin because it can be flexible if printed in thin sheets, allowing the skin to be perfectly attached on the curved surface. And with 3D printing, we can easily put on details like the rivet bolt, flare gun barrel, and the headlights. After printing all the parts, we simply painted them and put some weathering effects on them and to bring out the antique look. The result is amazing, and details really stand out even under close shot. The next example is also a prop for the same customer. This is a one-to-one sci-fi style helmet. And in this case, some of the parts are too large to be printed with Form3. So we combined EVA form and 3D printed parts in this case. As you might have known, many cosplayers use the same approach to make their costumes. We chose clear resin to print the 3D printed parts because the details can stand out nicely, and it's easy to sand, easy to paint, and we can easily put on some lighting effects just like the picture on the right. The next example is a typical prototype of technology product. It's a Wi-Fi bridge, meaning data comes in from the USB connectors and then sent out through Wi-Fi network. Such product usually comes with a printed circuit board inside, connector outlets, bottom cap, and LED indicators. The design challenges have always been making sure there is no mechanical interference between the parts, and the gap of movable parts is properly set according to the manufacturing tolerance. In the past, when 3D printer is yet available, small parts like bottom cap and LED light guide were handcrafted during the prototype phase, meaning the parts can be too small or too large, and it's impossible to tell if the bottom's click feeling is right or the LED light is leaking elsewhere. Today, such small parts can be 3D printed with high dimensional accuracy. Parts like bottom cap or the LED light guide can now be printed and verified in one shot. It really helps expedite the design verification process. And again, this case, clear resin is used, which is good for examining whether there's mechanical interference inside. And with a little effort of prying, sanding, and painting, the appearance of prototype can look just like final product. The next example is a tube adapter for laboratory centrifuge. The adapter is supposed to be inserted into the rotor so that smaller tube can sit tightly in the rotor without gap. The challenge here is when the machine is running, the rotor can go extremely fast, and even the slightest gap between the tube and the adapter can cause severe vibration and break the tube. Therefore, the dimensional precision of the adapter is a critical factor here. We printed the adapters with TEP 2000 resin because it's stiff enough to hold the tube in place, and in the same time, it's elastic enough to protect the tube as a cushion. As a result, the printed adapter fit the hole so well that when we inserted the adapter into the rotor, it pushed out all the air in the hole and made it difficult to put it out again because of the vacuum condition in the hole. This shows that the printing precision of Form 3 is really amazing. And the next example is a headset for EEG measurement. EEG stands for electroencephalography, meaning the brain activities are captured by electrodes attached to the head, and the result is presented in the form of electronic signals. The customer is a research institute, and the request is to design a headset which can not only hold the electrodes, but also be adjustable so that it could fit people with different head size. In other words, the shape and size of the headset needs to be adjustable, and the electrode holders should be able to move around. We came up with the structure as shown in the picture. As you can see, the length of each frame can be adjusted according to the head shape, and there are 2 electrode holders on each frame which can be moved around. And the head girth is also adjustable by turning the big knob below. We firstly printed with PETG using FDM 3D printer, as you can see in the picture on the left. Because PETG is known to be resilient to frequent bending, the result is pretty good. And later we came across the newly released SLS 3D printer, aka Fuse One. Thanks to our partner Taiwan Tima, who helped us to print the one on the right with nylon 11, which is also ideal for parts that needs to bend a lot. It turns out the result is even better than the one we printed with PETG. Firstly, even though PETG is resilient to bending, over time, the filament can start to peel off from the perimeter. Secondly, on FDM printer, the parts are better off being printed flat and bent later during the assembly. Why? Because we don't want to print it with supports and leave uneven scar on the surface. As a result, the headset is relatively stiffer and less comfortable to wear because the frame is constantly under bending force. On the other hand, with Fuse One, the parts can be printed directly in curved shape because it needs no support, which makes the headset more flexible and more comfortable to wear. And of course, the powder has been fused together, so we don't need to worry about the material being peeled off over time. The next example is an automatic feeder for pets. It's a standard IoT application, and it's designed to dispense pet food on a timely basis. The pet food is stored in the barrel and is pushed out by the screw conveyor, which is driven by a DC gear motor. The feeder is controlled by a separate control box which is able to connect to Wi-Fi and get an update of real time from the internet. Most of the parts were printed by Fuse One using nylon 12, and we specifically printed the chamber of screw conveyor with clear resin in order to see how the screw conveyor works inside. And as the prototype is relatively large, it was designed to be composed of several parts. And therefore, it's a good example showing how we used to assemble 3D printed parts with screws. For the parts that needs to be disassembled repeatedly, we embedded copper nut in advance so that threads of screw hole won't be worn out over time. And for the parts that won't be disassembled repeatedly, we simply use self-tapping screw and screwed it into a smaller hole on 3D printed parts. In our experiences, as long as the size of screw hole is probably set, the strength of 3D printed parts have no problem holding the screws and keeping the assembled parts in place. In summary, with the help of 3D printing, we have better efficiency. We can reach out to more customers from different sectors, and the customers are happier with our works. On the other hand, our delivery time is down. The need to outsource is down because we can pretty much do everything by ourselves, which also means our cost is down. So in general, we're glad to incorporate 3D printing in the beginning of our business. So that's all I have, and I hope you enjoyed the presentation. I look forward to seeing you guys again to share more experiences as Formlabs user in the future. Thank you.